Hi everyone, hope you are doing great. My name is Akshay. I work at Quill audits, and today in this video we are going to explore ERC-46 tokenized vault. So let's begin. Let's start with what is vault. So in simple words, vault is your automated investment manager of your tokens or assets. So user can simply deposit their assets into the vault, and in returns they will receive vault token, also known as shares, and these shares will represent their proportional ownership into that particular vault. So uh, ERC 4626 standard got introduced in 2022, but prior to that, whenever any developer is creating a vault, they used to create their own custom interface for the functionalities into the vault. And that time, integration of their vault with any third party protocol or with other vaults was extremely hard, and uh, the attack security attack surface was very large because of the custom code. Also the integration, uh, interoperability was also a major concern. So in order to eliminate this issue, ERC-46 standard came into the picture. It has tokenized the vault, and it is uh, built on the top of ERC-20, means it supports and it is compliant with ERC-20 token standard. So ERC-20 tokens are only used in ERC-4626 standard. Uh, if you have a token which is not ERC-20 compliant, then you might not be able to interact with that vault or participate in that vault. So this is one important thing to notice. Let's explore more. What is ERC-46 tokenized vault? What are the functionalities into it? How it works? And what are the attack surface or attack scenarios associated to it? So let me just open a document for you. So yeah, so this is ERC-46 tokenized standard research doc created by Quill audits team, and here you can see the functionalities of 4626 standard. So there are various functionalities like deposit, mint, preview, limit out, withdraw, and redeem function. As I mentioned earlier, only ERC-20 underlying assets are compatible with this standard. If the token is not ERC-20 standard, then you might not be able to participate in this vault. And now let's go deep into each functionalities. So the major functionalities are deposit, mint, withdraw, redeem, and accounting functions like convert to shares, convert to assets. So let's try to understand this functionality in much practical way. So this is a vault. You can give any name to the vault, and let's take an example of Alex. So Alex have 1000 USDT with him, and he want to invest 500 USDT into the vault. So when Alex is clear that he just want to invest 500 USDT into the vault without thinking how much share he will get, he can confidently use deposit function. So Alex have 1000 USDT, but he decided to invest 500 USDT into the vault, and for in order to invest 500 USDT, he need to use deposit function. While using deposit function, he just need to enter the amount he want to invest, and he will receive equivalent amount of shares in his wallet. Suppose another scenario. Now Alex has lot of money, and he is not thinking of money. He just explored any particular vault. He liked it. He checked what are the DeFi strategies in it, and how the yield generation will happen, and he uh, got excited and he really want to invest his money into that particular vault. And in that vault he just want 1,000 shares out of it. He's not thinking how much money he will require for those 1,000 shares, but he's clear that he want 1,000 shares only. So when he's clear that he want 1,000 shares, then he will use mint function from ERC-4626 standard. So this is the difference between deposit and mint function. I hope you are clear with this. Let's now jump on withdraw and redeem function. Now let's again consider Alex example. Alex has already deposited 500 USDT, and he must have received some shares. For example, 480 shares. Consider 480 shares, and it's been 2 or 3 months he has deposited it, and now he want to withdraw 250 USDT. So he's clear that he just wanted to withdraw 250 amount of USDT, because he might be in some need. So when he is clear how much amount he want to withdraw, at that time he can simply use withdraw function. And now consider another scenario where Alex is clear that he has 1,000 shares, but out of 1,000 shares he just want to uh, just want to take out 200 shares. So when he's clear how much amount of shares he want to take out, then he can use redeem function. So here he want to take out 200 shares, so he will use redeem function. I hope you have understood the difference between withdraw and redeem, as well as deposit and mint. Now let's get on a next concept, which is like, if Alex is depositing 500 USDT, how much amount of share he will receive? And if Alex want 1,000 shares, how much amount of assets will be required for him to invest, like how much will be deducted from his wallet. So there is a conversion formula: convert to asset and convert to shares. So let me write down the formulas for you. So the formulas are like, convert to assets. So yeah, let's look into the formulas, how the conversion happens in the backend. So these are the formulas. Yeah, so when Alex is depositing 500 USDT, then how much share he will get? So in order to perform that in the backend, this formula works: convert to shares is equal to assets into total shares upon total assets. So let's take an example. Total assets in the vault is 1050, and total shares is 1000. And Alex want to invest 500 USDT. So how much share he will get? So Alex shares 500 into 1000 divided by 1050, which is, let's check how much it will be. it will be around 476. So around 476 something shares he will receive. And if Alex want to mint 250 shares, then how much asset he will need to put in? So for that, similarly, we will use the formula. 250 is the amount of share he want, and to total asset at that moment in the vault is 1050 divided by total shares, which is 1000. So let's see how much asset will Alex require. Around 262 worth of assets he will need in order to get those 250 shares. So I hope you understood this formula well. So this is the core formula which is the backbone of this vault ERC-46 tokenized standard. Let me also show it into the code base. So let me open the open Zeppelin code ERC-4626 abstract contract for you. Sir, so here you can see all the functionalities. So this is a deposit function, mend function, withdraw function, redeem function, and here is the internal functions: convert to assets and convert to shares. So convert to shares, so how much asset Alex is putting into the vault, and in returns he will get the number of shares. So the formula is written here: total assets multiplied by total supply into total asset. So this is the formula, and this formula you can see there is a rounding +1. So this is done in order to get rid of the fractional part. So I hope you understand it. Similarly, here is convert to asset function as well. Now let's look into attack vectors associated with ERC-4626 tokenized vault. So there are a couple of attacks, but let's explore for now share price manipulation attack, also known as inflation attack. You can read more about it into our document. So yeah, these are the issues, and the issue which we are going to explore now is the share price manipulation attack, also known as inflation attack. So here are the steps mentioned, also the code snippet, but let's look into it practically. So let me open the remix IDE, and I have already written the ERC-4626 vault contract here. So now let's execute it. So it is already compiled successfully. Let me deploy it. So to deploy it, we first need to select the token contract, and this is a token contract. We need to add the name of the token. So for now, let's say the token name is Quill token, and the symbol is also Quill. Yeah, so transaction is successful and our token is deployed. Now let's deploy the vault contract. So this is our vault contract. Here we need to add the name of the vault, symbol, and asset. So asset is the one which we just deployed. So ERC20 token contract address, we need to paste it in the asset field. And if you remember, in the starting of this video, I have mentioned that ERC-4626 vault standard only supports ERC compliant token underlying assets. So here we have a ERC token deployed. We are pasting the address and the name of the vault. You can give any name, but for now let's name it as ABC vault, and the string is also ABC transact. Yeah, the transaction is successfully done now. So our token is also deployed, our vault is also deployed. This is our token address, this is our vault address. Now let's take the example of Alex and Bob. So let's consider this address as a Alex address, and Alex is also the attacker in our example here. So let it note down somewhere. So yeah, this is the document. Let's note down here itself. So Alex, who is also the attacker in this case, his wallet address, and Bob, this is the Bob wallet address. Now let's go into the Alex wallet, and now we are going to first mint the tokens into Alex and Bob's both account. So let's get into the token contract. First we have to mint it. So here is the Alex address, and how much amount we are going to mint. Let's mint 1000 ETH. Done. So 1000 tokens are minted into Alex wallet. At the same time, let's give the approval to vault to spend 1000 ETH from Alex wallet. So spender will be the vault, so we have to copy the vault address and paste it here, and we need to mention the amount as well. So let's put amount as 1000 ETH and transact. So yeah, Alex has given the approval to the vault contract address to spend 1000 ETH. Now let's do the same process for Bob. We have taken the Bob's wallet address. Now we are going to mint 1000 ETH to Bob as well. Done. Similarly, Bob is also giving the permission to vault to spend the 1000 ETH. Done. So now Alex and Bob both has 1000 ETH in their wallet, and they have also given permission to the vault to spend 1000 ETH on their behalf. So now let's start the attack. So first of all, let's go into the vault contract, and let's see what's the total supply. Sorry, this is not the vault, this is a token. Here is the vault. So total supply is 0, total asset is also 0 at the moment. So now Alex, who is the attacker, he is going to first deposit a small amount. So let's say 1 ETH, one way, and that deposit 1 way. Let's not deposit, let's mint 1 share. You can use anything, but for now let's use mint. So 1 share, and the receiver address is our Alex. So 1 share has been minted. Let's see what's the total asset now. Total asset is 1, total supply is also 1. Let's note it down as well. So Alex, this is a address, and this is Bob address. Both have 1000 token each. And step 1, Alex minted 1 share total supply is 1, total share is also 1 now. Step 2, Bob is going to deposit 1000 ETH or maybe 100 ETH in the vault. So we have to assume certain conditions here because practically we won't be able to perform the attack. So this one step 2 we need to assume it that Bob is going to deposit 100 ETH into the vault, and that transaction Alex uh, observe it in the meme pool. So Bob is going to deposit 100 ETH in vault, and Alex it in meme pool. So before Bob's transaction actually get executed on chain, Alex will deposit, sorry, the Alex will transfer certain amount to inflate the price of the share. So Alex will not use the deposit function. So please note it down here. ERC-4626 has a deposit and the mint function, but Alex is not using any function now. Here he is transferring 100 ETH into the vault address by using the transfer function in the token contract. So Alex will transfer 100 ETH into vault before Bob's transaction is executed. So we have assumed the scenario that in Alex is observing the main pool, and in the main pool he saw that Bob is doing the transaction. So before his transaction actually gets completed, Alex is going to transfer 100 it. So let's go into the Alex. Yeah, we are into the Alex wallet, and now let's go into the token contract mint function, and let's copy paste the vault address here. So this is our vault address, we have copied it, now pasting it down here. So this is vault address, this is the amount, and we are going to mint 1000. Oh sorry, we are not going to mint, we are going to transfer. Yeah, so we are going to transfer 100 ETH. Yeah, so transfer is successfully done here. Now before Bob's transaction is executed, Alex has done the transfer, and let's see what is going to change here. The total supply is as it is, it's 1, means the share is still 1, and total assets, so the total assets is increased a lot. That means the price of one share has exponentially gone up before the Bob's transaction is actually completed. Now let's see further. The Bob's transaction is going to complete now, so let's practically do it. So let's go into the Bob's account, copy the Bob's wallet address, and let's get into the vault and let's deposit. So we are going to deposit 100 ETH, and the receiver will be the Bob, who is the innocent guy in this scenario. Yeah, this is the Bob address. Yeah, so Bob's transaction is also completed now. And let's observe what will be the total assets and total supply now. So total supply is still 1, total asset is 2x now. So the one share price has gone extremely up. And now let's get into the Alex account, who is our hacker. He has successfully manipulated the exchange rate, and as soon as the price has inflated, he is going to redeem his proportion from the vault. So here he is going to use the redeem function into the vault. mm, yeah, this is the redeem function, and one share Bob have, and sorry, Alex have, and this is the Alex address, receiver as well as the owner. So we have added the share one and receiver and the owner. Address is Alex, who is our attacker, and we have done the transaction. So the transaction is successfully now. And let's see what is the total assets and total supply now. So total supply is 0 and total asset is also 0. So Alex has successfully done the hack, and he has drained out all the shares and assets from the vault by inflating and manipulating the exchange rate between the assets and share. So this is a very famous attack in the vault, and this is done when the vault is launched, and this can be mitigated very easily by at a deployment time by minting or depositing some shares in the start. And now let's get into another small attack, but which is also very interesting one, the sandwich attack. So let me explain it. So sandwich attack can be done at any stage of the vault. It doesn't need to be done in the launch of the vault. So in a vault, uh, as you know, there are different complex DeFi strategies which helps to earn or generate more yields. So once the yield is generated, it gets added into the vault by using a add yield function. So here on my screen you can see there's a add yield function written down. So with this function, the yield get added into the vault. So what attacker does here is he front run the attack. So as we have just seen in the example, they front run it, and attacker like observe the meme pool. First he observe the meme pool very carefully, and like consider that he has seen that a yield is going to get added into the vault. So just before that he front runs it by depositing a large amount of asset into the vault, and he's making sure that he has a uh, highest or maybe the large proportion of ownership of the vault to himself. So he will take the large proportion of the ownership from the vault, and as soon as the yield get added, then the price of the shares will definitely will increase, and immediately he will withdraw all his funds. So this is kind of sandwich where first he front runs, then withdraw, or like front runs, then the yield get added, the price of the shares increases, reward, interest, fee, everything increases, and after the increase he immediately like back run, withdraw, redeem all the proportion of his share and make a good amount of profit. So this is a sandwich attack, and there are few more attacks. You can go through those attacks from this document. We will attach the link here. And yeah, this is all about ERC 4626